I'm going to do a quick little video on something that causes me a bit of confusion around sine curves, sine waves. So I'm going to write there y equals sine x, which could really be rewritten as, because there's a 1 in front of that there, really. It's just assumed in algebra. It can really be rewritten as y equals sine of a x, where in this case a equals 1. You see, a lot can be found out from this a. We can find out things like, we can find out the frequency of the wave. We'll give that the symbol f. And we can find out the period of the wave, and we're going to give that the symbol t, like a physics symbol. I'll quickly draw a little sine wave here. That's the y-axis, this is the x-axis. And what I'll do is, there it is, and now look, it just keeps repeating itself. Go off the dotted line there, it repeats itself. In fact, this wave, this sine wave repeats itself every t units of x. It repeats itself. I'll tell you now that it's roughly 6. 1, 2, 3. Where I get the 6 from is the 6 is 2 pi. So really it's not really 6. It's 2 lot to 3.14, which is 6.28. But I'll just go with pi as 3 for now, just for argument's sake, to make the video a bit more easy to understand. Okay. So the period is the number of units of x it takes for this wave to repeat itself. The frequency is the number of waveforms that exist in every unit. So if this was 6, you can only see only 1/6 of the wave is occurring in each of these units. So we'd say it has a frequency of 1 on 6. 1 on 6.28, but just call it 1 on 6, 1/6. 1/6 of a wave for every unit of x. If it's time, we would call this a cycle or a wave per second, which is called a hertz, but I'm not going to hang up on that. I'm not going to go physics on us. We're not going to talk about physics. Y equals sine x. We've already seen that it has a period of 2 lots of pi. I've just said that, which is 6.28, but just accept that for now. I don't want to go too mathematical or too physics on this. Y equals sine x. There's a 1 in front, same as y equals sine of ax, but a is a 1. And it's the same as y equals the sine. I'm a terrible writer, I apologise. But I'm not doing this video again, I'm over it. Same as y equals sine of 2 pi f x. Same as y equals the sine of 2 pi over t x. And that's because f equals 1 on t. There's a relationship there, but just accept it. So what we can tell then is if a is 1 and a is also 2 pi f and a is also 2 pi on t, we can write a little formula here saying a equals 2 pi f equals 2 pi on t. So we can work out everything from here. We can work out, therefore, the frequency must be a on 2 pi. Well, a is 1 in our case, so therefore in our wave, but a could be anything. Frequency is 1 on 2 pi, which is approximately 1/6. You check, that's correct. This wave, there are 1/6 of this whole wave occurs in every unit of x. 1/6 of the whole wave. So it has a frequency of 1 on 6. I guess if you gave it some units, you would call it 1 on 6 cycles per, I'm just going to call it unit x. As I said, if this was time, the cycle per second, times in a second, would be a hertz. What also pops out is t, therefore, equals, quickly rearrange it, t, the period, is equal to 2 pi on a, for whatever a is. Up here a is 1, but it could be anything. You work it out for that. Therefore, in our case, period equals, the period equals 2 pi on 1, which equals 2 pi. In other words, every 2 pi, and we're just going to call this, we're going to say this is approximately equal to 6, make pi 3, 2 3s are 6. The period is 6. See, period is 6. Every 6 units, after every 6 units of x, this wave starts to repeat itself. Cut. That's the end of the video. Just wanted to clear that up for myself and other people.